नमस्ते बच्चों, I am Jv'n Dr Surendra Kumar from the Department of Science under the Faculty of Education and Methodology. Today I will discuss the successive differentiation, which is the program BSc B.Ed PCM first sem, and the course is Differential Calculus and Analytical Geometry. The topic is successive differentiation. But first we understand what is the topic of successive differentiation. Suppose y is equal to ax plus b to the power n. If we have to derivative of this, then differentiating with respect to x, then this is y1. y1 means this will be the derivative with respect to x. We use the formula x to the power n. This is n. This is ax plus b to the power m minus 1 into a. Now again differentiating with respect to x, then this is y2 is equal to, this is constant a, this is m, and m minus 1, this is ax plus b to the power m minus 2 into a, means a square. Again differentiating with respect to x, again differentiating with respect to x, then this is y3 is equal to, this will be a square and m minus 1, m minus 2, and this is ax plus b to the power m minus 3 into a square, so this will be a cube. Now again differentiating with respect to x, then derivative of y3 will be y4 is equal to, this will be a to the power 4, this is m, so this is m minus 1, m minus 2, and m minus 3, and this is ax plus b to the power n minus 4. Right? Now we have to write the successive differentiation, means we have to determine the nth derivative of this function. Nth derivative of this function means, so this is yn is equal to y1, then only one a, y2, this is a square, and y3, then the expression contain the a cube, y4, the whole expression contain the a to the power 4. So if we find the value of yn, nth derivative of y, then it will be the a to the power n. Now see, n in first derivative, in y2 n minus 1, in third derivative n minus 1 n minus 2, and in fourth n minus 1 n minus 2 n minus 3, means the whole series is going to the less than this term. So we can write n minus 1, n minus 2, n minus 3, and so on. This is n minus 1. And we notice y1 ax plus b to the power n minus 1, y2 ax plus b to the power n minus 2, and y3 this is ax plus b to the power n minus 3, and y4 ax plus b to the power n minus 4. So this will be ax plus b to the power n minus n. Now again we can write this. This is yn is equal to, this is e to the power n. Now this can be written as n minus 1, n minus 2, n minus 3, and so on. This is m minus n plus 1, and this is ax plus to the power n minus n. Now in this whole term, we notice this is n minus 1, n minus 2, means next term is less than the previous term by 1. So we can again write this. This can be written as n minus n m minus n minus 1, m minus n minus 2, and last 3, 2, 1. Similarly, we will multiply in the denominator. So this will be m minus n, m minus n minus 1, m minus n minus 2, and so on. This is 3, 2, 1. Now, again we can write this yn. This is yn is equal to, this will be a to the power n. This is a to the power n, m minus 1, m minus 2. So this is m minus 1, m minus 2, m minus 3, n. This is m minus n plus 1. This is m minus n plus 1, and m minus n, m minus n minus 1, and in last this will be 3, 2, 1 whole upon n minus n, n minus n minus 1. This is n minus n, n minus n minus 1, m minus n minus 2, and so on, 3, 2, 1 into this time. Means this is ax plus b to the power n minus n. Now this can be written as yn is equal to, this is a to the power n, and this expression is factorial m. This is factorial m upon, this is factorial n minus n, and this is ax plus b to the power n minus n. Now again this can be written as d to the power n, the value of y means ax plus b, means this is ax plus b to the power n is equal to, this will be a to the power n factorial m upon factorial m minus n, and this is ax plus b to the power m minus n. This is the nth derivative of ax plus b to whole power n is equal to a to the power n factorial m upon factorial m minus n, and ax plus b to whole power m minus n. Now there is a question. If n is equal to n, means suppose we have the nth derivative, we have to find the nth derivative of ax plus b to the power n. Means this may be written as d to the power n. This is ax plus b to the power n is equal to. Now putting n is equal to n, then this will be e to the power n factorial n upon, this is factorial n minus n, and ax plus b to the power n minus n. So this will be d to the power n ax plus b to the power n is equal to a to the power n into factorial n. Means if nth derivative, we have to find the nth derivative and n, then this will be the a to the power n into factorial. But suppose in this formula n is less than n. But if n is less than n, then by this formula we can write d to the power n, this is ax plus b to the power n is equal to. Now m in place, then this is a to the power n factorial n, this is ax plus b to the power m minus n upon, this is n minus n. Since n is greater, n is less than n, then m minus n is less than 0. So d to the power n, this is ax plus b to the power n is equal to, this is a to the power n factorial n, and less than 0 means minus, so it will be the infinity and the 0. Means we have studied about the formula y is equal to ax plus b whole power n is equal to a to the power n factorial n upon factorial m minus n ax plus b to whole power m minus n. This formula is true only when if n is greater than n, and if in this formula n is equal to 10, then this formula converts in the form of e to the power n into factorial n. And suppose if in case m is less than n, then n minus 1 is less than 0, so it will be infinity, and something upon infinity is just 0. Now is that clear? Now the next question. But if we have to find d to the power n, this is ax plus b to the power minus b. If power contains in minus b, where p is greater than 0. So we let y is equal to, this is ax plus b to the power minus b. Now differentiating with respect to x. Now differentiating with respect to x, then this will be y1 is equal to, this is minus p and this is ax plus b to the power minus p minus 1 into a. Now again differentiating with respect to x, then this is y2 is equal to, this is a constant, minus p is also constant, and x to the power n, then this is minus 1 minus p, and this is ax plus b to the power minus p minus 2 into a, means a square. Now again differentiating with respect to x, then this is y3 is equal to a square constant and minus p minus 1 constant, and we use the formula x to the power n, this is nx to the power n minus 1, so this is minus p minus 2, and this is ax plus b to the power minus p minus 3 into a, so this will be a cube. Now again differentiating with respect to x. Now again differentiating with respect to x, then this will be y4 is equal to, this is a cube constant, and this is minus p, this is minus p minus 1, this is minus p minus 2, this is minus p minus 3, and this is minus p, this is ax plus b to the power minus p minus 4 into a, because the supposing term will be again differentiated to the same respect. So it will be into a, but a is cube, so it will be a to the power 4. Now we can write our analytic derivative successive differentiation of this function. So we can write y of n is equal to. Now we notice if y1 then 1a, y2 a square, and y3 a cube, y4 a to the power 4, and if we find yn then a to the power n. This is the series, just like the singularity. Now y1 minus b, y2 minus b minus 1, y3 minus b minus 1 minus b minus 2, and y4 minus b minus 1 minus 3 minus 2 minus b minus 3 means 4 then 3, 3 means 2, 2 means 1, decreasing by 1, the next term is decreasing by 1, so y in yn this can be written as minus b minus 1 minus b minus 2 minus b minus 3 and so on. This will be minus b minus decrease by 1, this is 4, then 3, this is n, means n minus 1, so n minus 1 into, now y1 ax plus b to the power p minus 1, y2 ax plus b to the power minus p minus 2, y3 ax plus b to the power minus p minus 3, and y4 means ax plus b to whole power minus p minus 4, so yn can be written as ax plus b to the power minus p minus n. Again, this can be written as yn is equal to, this is a to the power n minus p 1p. Here y1 minus 1, y2 minus and minus double time, minus 3 minus 3 and minus 1 to the power cube, y4 1 minus second minus 1 third minus 1 and 4 1 minus 1 to the power 4. So in yn minus 1 to the power n. Now in bracket this will be p plus 1, p plus 2, and this is p plus 3 and so on, p plus n minus 1 into, this is ax plus b to the power minus p minus n. Now again yn is equal to, this is same, a to the power n minus 1 to the power n. Now we notice p plus 1, p plus 2, p plus 3 and so on, p plus n minus 1. If we write the previous term of the p, then it will be the p minus 1. So it will be p plus 1, p plus 2 and so on, p plus n minus 1. And the previous term of that, this will be p minus 1, p minus 2, p minus 3, and in last 3, 2, 1, whole upon, this is 1, 2, 3, and this is p minus 3, p minus 2, and p minus 1, and this is ax plus b to the power minus p minus n. So this is yn is equal to, this is a to the power n, this is minus 1 to the power n. Now this is p plus n minus 1 and decreased by 1, then 3 to 1, so it will be the factorial p plus n minus 1. So this is factorial p plus n minus 1 upon, this is p minus 1, p minus 2 and so on 3 to 1. So it will be factorial of p minus 1. And this is ax plus b to the power minus b minus n. So this is the nth formula for the a to the power yn is equal to a to the power n minus 1 to the power n factorial p plus n minus 1 whole upon p minus 1 into ax plus b to the power minus of p minus 1. This is also the standard formula for nth derivative of the function y is equal to ax plus b whole power minus p, where p is greater than 0. Now, what formula is similarly? If we have to find y e to the power n, this is ax plus b to the power minus 1. Then we put y is equal to ax plus b to the power minus 1. It means here only p is equal to 1. So this will be the y1 or putting p is equal to 1. Then this will be d to the power n ax plus b to the power minus 1 is equal to, this is a to the power n, this is a to the power n minus 1 to the power n, and p is equal to 1. Then this is cancel out and this will be factorial n upon p is equal to 1 is factorial 0, and this is ax plus b to the power minus 1 minus n. Again, this can be written as d to the power n ax plus b to the power minus 1 is equal to minus 1 to the power n factorial n a to the power n upon this is ax plus b to the power n plus 1. This is the formula for the nth derivative of ax plus b to the power minus 1. Now the next formula is now, if we have the function y is equal to, or we have to find nth derivative of e to the power ax plus b, then the same process we can write y is equal to e to the power ax plus b. Now differentiating with respect to x. Now differentiating with respect to x. Then this will be y1 is equal to e to the power x, means e to the power ax plus b into a. Again differentiating. Again differentiating with respect to x. Then this will be y2 is equal to a constant, and the derivative of this again will be same. So this will be a e to the power ax plus b. It means this can be written as a square e to the power ax plus b. Now again differentiating with respect to x, then this will be y3. So this is y3 is equal to a square will be the same, and the derivative of this will be e to the power ax plus b into a. So it will be a cube into e to the power ax plus b. again differentiating with respect to x. So this is y4 is equal to, this is a cube and this is e to the power ax plus b is equal to a cube into a means a to the power 4 e to the power ax plus b. Now we can write the nth derivative. So d to the power n e to the power ax plus b is equal to. Now notice y1 only 1a, y2 contains the a square, y3 contains the a cube and y4 contains the a to the power 4. So yn contains the means nth derivative contains the a to the power n. Now y1 e to the power ax plus b, y2 e to the power ax plus b same, y3 e to the power ax plus b same and y4 e to the power ax plus b same. So it means in nth derivative e to the power ax plus b. This is the standard formula for e to the power ax plus b. Now the next formula. Suppose we have to find d to the power n ax. What is the nth derivative of a to the power x? Then there is no problem. Only we can write this y is equal to a to the power x. Now differentiating with respect to x. Now differentiating with respect to x. So it will be y1 is equal to a to the power x. A to the power x means a to the power x derivative a to the power x log a to base e. This is log a to base e. Now again differentiating with respect to x. So this will be y2 is equal to, now log a to base e is constant, so this is log a to base e is constant. A to the power x means a to the power x log a to base e. So this can be written as log a to base e to the whole square into a to the power x. Now again differentiating. Now again differentiating with respect to x. So y2 convert to y3, so this will be y3 and log a to base e to the whole of square will be the constant, so this will be log a to base e to the whole cube, square constant, and the derivative of a to the power x means a to the power x, this is log a to base e. Again this can be written as this is log a to base e to the whole cube into a to the power x. Now again differentiating with respect to x. Now again differentiating with respect to x, then this y3 in the form of y4. Derivative of y3 is y4. So this is y4 is equal to, now log a to base to the whole cube is constant. So this is log a to base e whole cube is constant, and the derivative of e to the power x. The derivative of e to the power x is e to the power x into log a to base e. So this can be written as log a to base e to the whole power 4 into e to the power x. So we can write the nth derivative of e to the power x. Nth derivative of a to the power x. Now we notice here, first derivative is only log a to base e as a constant. And in the second derivative, log a to the whole of square, log a to base e to the whole of square is the constant. And in y3, log a to the base e to the whole of cube is constant. So y4, fourth order derivative of this contains as a constant this time. So the nth derivative will contains as a constant log a to the whole cube whole power n. Now y1, first order derivative only a to the power x. Second order derivative, this is a to the power x. In third order derivative, this is a to the power x. And the fourth order derivative is a to the power x. So nth order derivative contains the a to the power x. It means nth derivative of e to the power x is equal to, this is log a to base e whole power n into e to the power x. This is the nth derivative formula for the a to the power x. Now suppose, now we see the next question. Now suppose it is given that the logarithmic function, suppose it is given that d to the power n log of ax plus b. It means we have to find the nth derivative of log of ax plus b. Then how we can solve? Then process will be the same. This is the derivative of formula. So suppose y is equal to log of ax plus b. Now differentiating with respect to x. Now differentiating with respect to x. Then this will be y1 is equal to log of, it means this is 1 upon ax plus b into a. So we can write this y1 is equal to a and ax plus b to the power minus 1. Now this is the first order derivative of log of ax plus b. Now again differentiating with respect to x. Then the derivative of y1 will be y1 is equal to, a is the constant, a is constant. Now ax plus b to the power n minus 1 will be treated as ax to the power n. X to the power n derivative, then nx to the power n minus 1. So this can be written as minus 1 and this is ax plus b to the power minus 2 into a. It means we can write this y2 is equal to a, this is minus 1, a square minus 1 and ax plus b to the power minus 2. Now again derivative. Now again differentiating with respect to x. Then this will be y3 is equal to a square constant minus 1 constant. So it will be a square and minus 1. Now it will take x to the power n. So it will be minus 2 and ax plus b to the power minus 3 into a, because ax plus b is treated as x. Then y3 can be written as a square a cube. This is minus 1 minus 2 and ax plus b to the power minus 3. Now again differentiating with respect to x, then this will be y4. So it is a cube, this is minus 1, minus 2 and minus 3 and ax plus b to the power minus 4 into a. So this can be written as y4 is equal to a to the power 4. This is minus 1, minus 2, minus 3 and this is ax plus b to the power minus 4. Now if we determine the nth derivative, then we notice now all other derivatives. First order derivative contains only one a. Second order derivative contains a square. Third order derivative of log of ax plus b contains a cube. And fourth order derivative a to the power 4. It means it is noticed the order of the derivative is same as the power of a. So it can be written as e to the power n. Now again y1, first derivative of y is a. So y2 minus 1, y3 minus 1, y3 minus 1 minus 2, y4 minus 1 minus 2 minus 3 means 1 minus 1 minus 2 minus 3 and so on minus of n minus 1. Again y1 ax plus b to the power minus 1, y2 ax plus b to the power minus 2, y3 ax plus b to the power minus 3 and notice y4 ax plus b to the power minus 4. So it will be ax plus b to the power minus n and the times minus n. So it is yn is equal to, this will be a to the power n and y2 only 1, y3 minus 1 square common, y4 minus 1 cube common, yn minus 1 to the power n minus 1 common, and the remainder is 1, 2, 3 all term will be the positive, then 1, 2, 3 and so on n minus 1, and this is ax plus b to the power minus n. So this is yn is equal to a to the power n and minus 1 to the power n minus 1, and this is factorial n minus 1, and this is ax plus b to the power minus n. It means the nth derivative means d to the power n of log of ax plus b can be written as minus 1 to the power n minus 1 factorial n minus 1 e to the power n upon ax plus b to the power n. This is the nth derivative of this ax log of ax plus b. Now we see the next one. If we have to find d to the power n sine of ax plus